Hi teacher, this is Jesus Andres again in my first exam of differential calculus, and this is the book that I'm using for my exam calculus for business, economics, life sciences and social sciences 14th edition from Raymond A. Barnett, Michael R. Ziegler, Carl E. Bailey and Christopher G. Stoker. The problem that I've selected in order to solve the first part of this exam is this one. 65. Underwater pressure. At sea level, the weight of the atmosphere exerts a pressure of 14.7 pounds per square inch, commonly referred to as one small atmosphere of pressure. As an object descends in water, pressure P and depth D are linearly related. In salt water, the pressure at a depth of 33 is 2 atms or 29.4 pounds per square inch. So first of all, the problem states that we need to find the linear model that relates the pressure P in pounds per square inch to depth in feet. To interpret the slope of the model and to find the pressure at a depth of 50 feet and find the depth at which pressure is 4 atms. So as we are talking about linear equations, we are going to refer to this one, y equals mx plus b. So that's the point slope equation. So the problem states that the pressure is equal to 1 atmosphere or 14.7 pounds when we are at sea level. So Ft is equal to 0. So we can start stating that our problem is going to be solved of this form. P of D is equal to M times D plus 14.7 pounds per square inch. And in order to solve what's M, we are going to use the equation of M of its y sub 2 minus y1 over x2 minus x1. So that's 29.4 minus 14.7 over 33 minus 0. That is equal to this and equal to this in fraction, or in decimal 0.4454 pounds for every feet. So when we go down 1 feet, we are increasing this pressure. So that was stated. The point 0 at sea level is that, and the point 1 is at 33, that it is stated right here. 30 feet is 2 atms, that is 29.4 psi. So we obtain that the equation and the first part to find the linear model. P of D is equal to 49 over 110 times D plus 14.7 psi. And the point C, interpret the slope of the model. We have done that right here because we took the point number 0 and the point 1 and we did that operation, and with that we are interpreting that every foot we are going to increase that pressure. So if 1 atmosphere is equal to 14.7 pounds over square inch, 4 atmospheres is going to be equal to 58.8 psi. So that's for find the pressure at a depth of for this one, find the depth at which pressure is 4 atms. So 4 atms is going to be equal to that. So 58.8 psi is going to be equal to 49 over 110. Sorry, I did a mistake right there. Really? 110 times D plus 14.7 psi. So we can move a little bit that because we want to know this value D. So 58.8 psi minus 14.7 psi divided by 49 over 110 is going to be equal to D. And making that operations, we are going to obtain that is going to be 99 feet. So that's the depth at which pressure is 4 atms. And for C, find the pressure at that depth of 50 foot. We only replace that in the original equation, linear equation, right there. 50 foot, so P of 50 is going to be equal to 49 over 110 times 50 plus 40.7 foot over square inch. That is going to be equal to 36.9727 psi. So that's all for the first part. Let me write the second and record it. So well, the second problem of quadratic equations is the problem number 90, outboard motors. The table gives performance data for a boat powered by a Evinrude outboard motor. Find a quadratic equation regression model y equals ax squared plus bx plus c for fuel consumption y in miles per gallon as a function of engine speed in RPM, revolutions per minute. Estimate the fuel consumption at an engine speed of 2,300 RPMs. So the table is right there. So RPM and miles per gallon. And in my calculator, I use the function of quadratic regression. I only needed to put this because this is the independent variable and this is the dependent variable. It is stated right here. So the A, B, and C factors are those, and they're just there in the whiteboard. So the only thing that we need to do to estimate the fuel consumption at an engine speed of 2,300 RPMs is to solve that equation, replacing the x squared by 2,300. So let me make that operation and I'll come back. So well, performing the operations, we obtain that y is going to be equal to 5.4485 miles per gallon, and comparing with the result that I obtained in my calculator and writing that expression in GeoGebra, I obtained that when x is equal to 2,300, we have this point of intersection with the function, and when x is equal to 2,300, this is almost the same. Well, that's the same of my calculator. So that's the general, that's the quadratic equation. So it is a really big parabola. So that would be it. Thank you very much, teacher, and see you later.